Hello everyone, welcome to my YouTube channel Physics with Dr. Sanjay Bhargav. Hope you have been enjoying the basic concepts of physics with us. In this video, Theory of Errors, we are introducing the words like errors, accuracy, precision, least count, vernier caliper, screw gauge. Also, we will discuss about the different types of errors like the systematic error, the instrumental error, the personal error, the random errors, the least count errors. We would also try to quantify the measurement of errors through absolute error, mean, absolute error, the relative error, the percentage error, and how do the errors propagate in the mathematical operations of addition, subtraction, multiplication, and division. Hope you will enjoy this video as our earlier videos. We begin with the sentence, measurement is the foundation of all experimental science and technology. The result of every measurement by any measuring instrument contains some uncertainty. So we pick up with describing the word called error. Error. The uncertainty present in a measurement would be called as error. Then we have another word called accuracy. The accuracy of a measurement is a measure of how close the measured value is with respect to the true or mean value of the quantity. The best measured value of any measurement is supposed to be the average value. If I make a measurement, then that measurement would be called accurate if it is very close to the true or the mean value. Then we have a word called precision. Precision in a measurement tells us the limit of resolution up to which the measurement has been made. The precision always depends on the least count of the measuring instrument. So what does the precision tell us? Precision tells us the limit of resolution up to which the measurement has been made. So limit of resolution could be up to single decimal place, up to second decimal place, or up to third decimal place, which would be decided by the least count of the measuring instrument. Now the basic word is, what is least count? So how do we describe the least count? The least count is described as the smallest division that we can measure with the help of a measuring instrument. So the smallest division that we can measure with the help of a measuring instrument would be called as least count. How do we mathematically calculate it? The least count would be given by value of one division on the main scale divided by total number of divisions either on the vernier scale or the circular scale. Vernier scale is present in the vernier caliper and the circular scale would be present in the screw gauge. So we have just a pictorial representation of a vernier caliper and a screw gauge in this page. This figure represents a figure for vernier caliper. These are the two jaws of the vernier caliper. Between the two jaws you are supposed to keep the item whose radius have to be determined, whose thickness is to be determined. This represents here the vernier scale, and this represents the main scale, and this represents the two jaws for measuring the inner dimensions. Now this vernier scale contains 10 divisions. In main scale you will observe that from 0 to 1 centimeter there are 10 equal divisions here. So what is the value of one division? It would be 1 by 10 of a centimeter, that is 0.1 centimeter. So we say a vernier caliper is a measuring device which is used for the measurement of linear dimensions. Also can be used for measuring the diameter of the circular objects or with the help of measuring jaws. Now how do we define the least count of the system? Value of one division on the main scale, and what was the value calculated by us? 0.1 centimeter. What was the total number of divisions on the vernier scale? 10. And that is why the least count, also called as the vernier constant, is equal to 0.01 centimeter. That means it can measure to the accuracy of the second decimal place. That is least count. Now we have another instrument called a screw gauge. A screw gauge, we have a spindle here, the screw. This represents the main scale. This represents the circular scale. Now this is a ratchet screw. As we move, this spindle moves inward. You can just fix a pen to measure the radius of the pen or the diameter of the pen between the two jaws. Again, what is a screw gauge used for? A screw gauge is a mechanical tool which is used to measure diameter, radius or the thickness of a thin wire or thickness of a thin metallic sheet with reasonable accuracy. Now, let us go back to the figure. On the circular scale, if we observe, there are 100 divisions, and for one division on the main scale, it is 1 by 10 of a centimeter, that is 0.01 centimeter. So what would be the value of the least count? Value of one division on the main scale, that is 0.1 centimeter, divided by total number of divisions on the circular scale. So the least count comes out to be 0.001 centimeter. That is, it can measure with the accuracy up to third decimal place. Hence, is considered to be more precise in measurement as compared to the vernier caliper. So accuracy of measurement may depend upon the limit or the limit of resolution of the measuring instrument. How? Let us pick up an example. Suppose the true value of a certain length is 3.678 centimeter. Using an instrument of the resolution 0.1 centimeter length, it is measured as 3.5 centimeter. And using an instrument of greater resolution, that is 0.01 centimeter, it was measured at 3.38 centimeter. So when it measured by the resolution 0.1, the reading comes out to be 3.5 centimeter. While measuring with the help of greater resolution 0.01, it comes out as 3.38 centimeter. Let us see what discrepancy does this produce. The first measurement 3.5 centimeter has more accuracy. Why? Because it is closer to something called the measured value 3.678, but has relatively smaller resolution. While the second measurement, that is 3.38, is more accurate but is less accurate but more precise. Thus every measurement that is made is an approximation due to the errors in measurement. Now let us come to what are the different types of errors that can be incorporated in a measurement. The errors are broadly classified as systematic error and the random error. Now let us pick up the first one, that is a systematic error. The errors which tend to be in one direction, either positive or negative, are called as systematic errors. The main source of systematic errors are instrumental error. That means systematic error means must show some order, some system in their error pattern. Either they can be all positive, could be all negative, could be all increasing, could be all decreasing, something like that. Some pattern should be observable. Then they are called as systematic errors. Where do they originate from? They originate from either the measuring instrument known as instrumental errors. These errors arise from the imperfect design or faulty calibration of the measuring instrument or the zero error in the instrument. In vernier caliper, the zero mark of the vernier scale may not coincide with the zero mark of the main scale. That would produce zero error. Meter scale by which you are measuring may be worn off at one end, may start from 2 centimeter instead of 0. So we'll have a error that has been contributed by the instrument. These errors can be minimized by replacing the instrument with proper calibration. So the only choice with us is to replace the instrument with a proper calibration. Imperfection in the experimental technique or procedure. Imperfection in the technique of measurement also contributes to errors. These errors are introduced due to change in external conditions like temperature, humidity, wind velocity, pressure, etc. during the experiment. Suppose I have a thermometer For small kids, the temperature is measured by putting the thermometer under the armpit. But this will always give a temperature which is lower than the actual value of body temperature. So we have an error introduced by the process of measurement. The third type of errors are contributed by the personal errors. These errors are due to the negligence of an individual performing the experiment. These may be due to lack of proper setting of the apparatus or carelessness in taking the observations without proper precautions. If we hold our head a bit high to the right while taking the position of the reed needle on the scale, then the error arises, and that is called as the parallax error. These errors are usually large and can be minimized only by repeating the experiment very carefully. Like, I measure a length and it was 5.1 centimeter and I unknowingly write it as 5.1 meter. That's the carelessness of an individual, which would generate a large amount of error. So you need to represent or repeat the experiment again just to have minimization of errors. Note, systematic errors are minimized by improving experimental techniques, selecting better instruments, and doing measurement very carefully. So that is why in the laboratory one must be very careful while doing the experiment so that the result or error in the result may be minimized. Then we have second category of errors as the random error. What does the random error say? Random, as the word says, just occurring by the matter of chance and may be very irregular in pattern. So the error which are introduced as a matter of chance or occur irregularly with respect to the magnitude and sign, then they are called as random errors. These arise due to random and unpredictable fluctuations in experimental conditions of temperature, voltage supply, mechanical vibrations of the experimental setup. Like the table on which you are doing the experiment, suppose somebody pats on it, then the vibrations are transferred to the experimental setup. If you are measuring some very precise quantities like in optics, then the results may be very poor. That is why we have to take care in doing the experiment. How do we minimize these errors? These errors can be minimized by taking observation large number of times and then calculating the average. So that is why in the laboratory the teacher always tells you repeat the experiment number of times, take large number of observations and then calculate the mean value. By taking the mean value, the random errors would be minimized. You cannot eliminate the errors to zero, but you can just work to make them minimized. We have another error coming from the least count of the measuring instrument. The least count error is associated with the resolution of the instrument. For all experiments, resolutions are different. Like we calculated for 1 year caliper, that was 0.01 centimeter. For the screw gauge, it came out to be 0.001 centimeter. And what is least count? Again, we define as the smallest value that can be measured by the measuring instrument is called least count. All the measured values are good up to this value only. This can be minimized using instruments of higher resolution or smaller least count. That is why a measurement done by the screw gauge would be better as compared to something called 1 year caliper. So we have to use instruments of better resolution or least count just to have proper measurement, precise measurement. Now, how do we express error mathematically? Then the way of expression is through either absolute error, the relative error and the percentage error. What is absolute error? The magnitude of difference between the true value or average value with the measured value of a quantity is called absolute error of a measurement. Now, absolute error in the measurement of x is represented by delta x. So modulus represent means absolute error would always be positive. It is equal to the difference of x mean minus x. Now, absolute errors are always positive. absolute errors are very small as compared to the measured value x. Delta x is very much smaller than delta x. The product of two absolute errors is negligible because it is a product of two small quantities like 0.01 into 0.01 would be equal to 0.1231. So this is very small as compared to the measured value of x, and that is why the product of two absolute errors would always be negligible. Then we use another word called mean absolute error. This is the arithmetic mean of all absolute errors. Delta x mean would be delta x1, delta x2 plus delta xn divided by n. Can be represented as summation I is equal to 1 to n delta xi upon n. If we do a single measurement, then the value we get would always lie in this range, x mean plus minus delta x mean. The lowest value possible would be x mean minus delta x mean, and the highest value measured can be between x mean plus delta x mean. So the result or the new measurement would always lie in this range. Then we have a word called relative error or percentage error. The relative error is the ratio of the mean absolute error to the mean value of the quantity measured. Relative error is delta x mean upon x mean. The relative error expressed in the percentage is called percentage error. Now percentage error would be relative error into 100, and then you can express it in percent. The accuracy of measuring physical quantities is compared by calculating relative error or percentage error. So if you want to compare accuracy, then it could be like 1%, 2%, 5%. So that would provide us a better idea of comparison. Now we pick up an example just to understand absolute error, mean absolute error, relative error and percentage error. In an experiment, the value of refractive index of the glass was found to be 1.54, 1.53, 1.44, 1.54 and 1.56 and 1.545 in successive measurements. So we made the measurement 6 times and we had 6 different results. We are asked to calculate mean value, second absolute error in the measurement, mean absolute error, relative error, percentage error, and another part also express the results in terms of absolute error and the percentage error. So let us first calculate the mean value. Mean value, sum all the 6, divide by 6, and that gives me 1.51 as the mean value. Now when we said absolute error, it was equal to x mean minus delta x1. So it is mu mean minus mu 1, and that is the absolute errors are always positive, so the difference comes out to be 0.03. Now we just see 0.03 is very small as compared to the measured value 1.54, and that is why we said absolute errors are very small as compared to the measured values, and the multiplication of two absolute error would be further small. Delta mu 2 you calculate here, 3, 4, 5 and 6. All absolute errors have been taken to be positive. Then mean absolute error, sum of all absolute errors divided by 6, and that comes out to be 0.04. Now relative error, it is delta mu mean upon mu mean, so 0.04 divided by 1.51, and that is equal to 0.03. We have rounded off the calculation. Percentage error is equal to delta mu mean upon mu mean into 100. That is 0.03 into 100, and that is 3%. Value of mu in terms of absolute error would be 1.51 plus minus 0.04, and in terms of percentage it is 1.51 plus 3%. Right? So I hope this example just makes you clear about the different words that we have utilized, that is the mean value, then the absolute error, mean absolute error, then the relative error, the percentage error. So all the 6 words introduced in this single example in the form of calculation, how to perform that calculation in numerical side. Now the question comes up is, how do the errors combine? When we say combination, that means Every result of an experiment is obtained by doing mathematical operations on several measurements. The final error depends not only on the errors of individual measurements, but also on the nature of mathematical operations. That means we have to understand how do errors combine under various mathematical operations of addition, subtraction, multiplication, division. The rule for sum and difference is same, and the rule for multiplication and division would also come out to be same. Let us check error of a sum or difference. So we say here we have two physical quantities A and B. The measured value of A would always lie between A plus minus delta A, and for B it would lie between B plus minus delta B. Here delta A and delta B are the absolute errors in the measurement of quantity A and B respectively. We like to find error delta Z in the sum Z is equal to A plus B. So express these values here. Z plus minus delta Z would be A plus minus delta A plus B plus minus delta B. So can be written in the form of equation number 2. Z plus minus delta Z would be equal to A plus B plus minus delta A plus delta B. Now what is Z? Z was equal to A plus B, so should cancel. So delta Z must be equal to delta A plus delta B. Similarly, check what happens in case of difference. Then let Z be equal to A minus B. So Z plus minus delta Z is A plus minus delta A minus of B plus minus delta B. So can be written as A minus B plus minus delta A plus delta B. Remember, absolute errors are always positive. So delta Z would be equal to delta A plus delta B. So we can now frame the rule for subtraction and addition. When the two quantities are added or subtracted, the absolute error in the result is the sum of the absolute errors in the individual quantities. Absolute error in the result was equal to absolute error in the quantities that were supposed to be added or subtracted. Now let us find out the rule for errors in product and quotient. So again, there are the two quantities A and B. The measured values would lie between A plus minus delta A and B plus minus delta B. Once again, delta A and delta B as usual are the absolute errors in the measurement of A and B respectively. Let the product be decided as Z is equal to A into B. Z plus minus delta Z is equal to A plus minus delta A into B plus minus delta B. On the right hand side, if I multiply by A, then it is A into B plus minus A into delta B plus B into delta A plus delta A into delta B. Remember, this is product of two absolute error, has to come out as negligible. Now divide both the sides by Z is equal to AB. So 1 plus minus delta Z by Z is 1 plus minus delta B by B plus minus delta A by A. This is small and division by AB would make it further small. So purely negligible. So delta Z by Z would be then equal to delta A by A plus delta B by B. Now let us check what happens in the quotient. If Z denotes the quotient of A and B, then Z would be equal to A plus A upon B. So Z plus minus delta Z would be A plus minus delta A upon B plus minus delta B, A into 1 plus delta A by A, B into 1 plus minus delta B. Z plus minus delta Z would be equal to Z into 1 plus minus delta A upon A into 1 plus minus delta B upon B ka inverse. Now, if I apply the binomial expansion, 1 plus x power n would be equal to 1 plus n times x. So I obtain here as it would be plus minus into minus 1 delta B upon B. So absolute errors is always positive, so I maintain 1 plus minus delta B. This can be written, I can multiply both the sides Z into this is again negligible. Now Z would cancel with this Z. After multiplication we obtain the three terms, and the three terms are Z plus minus Z delta B by B plus Z delta A by A. Z से Z cancel हो जाएगा. Divide by delta Z, divide by Z on both the sides, so I obtain delta Z by Z is equal to delta A by A plus delta B by B. The same rule for multiplication and the same rule for division. So we convert and make a rule now. When two quantities are multiplied or divided, the relative error in the result is the sum of the relative errors in the quantities to be multiplied or divided. Error in a measured quantity raised to a power. Now let us have a quantity A defined as A plus minus delta A. Let Z be equal to A square. So Z can be Z plus minus delta Z. On the right hand side we have A plus minus delta A ka whole square, which would give me A square plus 2AB plus B square. So delta A ka square is negligible. On the left hand side Z and Z would cancel out, so I'll get delta Z would be equal to 2A delta A. I can divide by Z is equal to A square on both the sides, so this will give me delta Z by Z is equal to 2 times delta A by A. So relative error in the Z, that is A square, is twice the relative error of A. So simple, power times the relative error of A. General relation for error involving powers of the measured quantities. We have Z is equal to some quantity A power P, B power Q and C power R. Then delta Z by Z would be equal to power times the absolute error delta A by A plus power times absolute error delta B by B plus power times delta C by C, that is the relative error in the measurement of C. So let us pick another example to understand the power concept. The percentage error in the measurement of mass and speed are 2% and 3% respectively. How much will be the maximum error in the estimate of kinetic energy? Remember, kinetic energy is E is equal to half mv square. So in terms of error, delta E by E, half is a constant, so cannot have error, delta M by M plus power times the absolute error delta V by V. So delta M by M given as 2%, delta V by V 3%, so that is 8 by 100. So percentage error in the measurement of kinetic energy would be 8%. Then I have another example. A physical quantity P is related to 4 observable A, B, C and D as follows. P would be A cube B square upon under root C into D. The percentage error in the measurement of A, B, C, D are 1%, 3%, 4% and 2% respectively. What is the percentage error in the quantity P? If the value of P calculated using above relation turns out to be 3.763, to what value should you round off the result? So we utilize the concept here. P is given as A cube B square upon root CD. So delta P by P would be 3 times the absolute error in A, power times 2 delta B by B plus power is half delta C by C plus power is 1 delta D by D. Delta A by A is 1 by 100, 3 by 100, 4 by 100, just substitute the values. So it comes out as 13 by 100. So what is the percentage error in the measurement of the result? It is 13%. If P is equal to 3.763, then delta P would be equal to 3.763 into 13%, that is 0.48919. This result is rounded to 3.8 as there is uncertainty with regard to second significant figure, that is 7. This is having some uncertainty. So after rounding off, this must come out as 3.8. Right? Hope the concept of errors, the origin of errors, the mathematical propagation of errors are very clear through this video to all of you. If you understand physics through this video, then we request you to like and comment on the video and also subscribe to my channel so that you can receive the notifications of further videos in time. Thank you very much. See you soon.